Hi guys, happy Testlation Day. I hope you guys are ready. I'm really looking forward to seeing those wow factors in your project. Let's go ahead and get started. The target today is that you are going to be able to solve similar figures for missing sides. So let's go ahead and take a look at that. Alright, go ahead and title this Similar Figures. And your essential question is, how can you use proportions to solve similar figures? First of all, similar figures are figures that have the same shape but not necessarily the same size. Mathematically, what you will see, because we like to shorten things if we can, what you will see in a picture, because we are talking about images, we're talking about objects, so we're talking about shapes, is that you'll have equal angles. All of the angles will be equal. Okay. By the way, this symbol right here with the squiggly with the equal sign underneath it means similar. Congruent. This means congruent. This little one squiggle means similar. So again, we like to shorten things up if we can. The big properties we're looking for similar figures is that corresponding side lengths are proportional, and we're going to talk about how we can use proportions to solve them, and corresponding angles are congruent, aka equal. So again, angles, this symbol means equal. The figure, this means similar. Congruent, proportional sides, and we're going to talk about proportional sides and review from last year. Alright, so let's go ahead and start jumping into our examples, okay? And remember, this means equal, congruent specifically, because we're talking about a shape, and this means similar. Alright, example 1. Which rectangle is similar to rectangle A? What are the two requirements for shapes to be congruent? Equal. Oh goodness, I'm like messing up. What are the requirements for two shapes to be similar? So similar, aka this symbol. Alright, the first requirement, equal angles. Angles are congruent, equal. That's what this symbol means. Alright, and the second one, proportional sides. Sides, proportional. Ooh. Rewind. My goodness, this tablet. Alrighty. Pretend like that line doesn't exist there. Okay. Equal angles. Luckily, for our first thing, all of these rectangles have equal angles because they're all going to be 90 degrees. That's a property that we know about rectangles, is that they have equal angles. Okay? We know that. So, yes, all of them have 90-degree angles. Now, sides are proportional. We're going to find the corresponding sides, matching sides, and see what they are. We're looking at 3 corresponds to 2 and corresponds to 2. Alright. 6 corresponds to 6 and corresponds to 4. So whatever we multiply rectangle A by needs to be the same number, okay, to get the next number. To go from 6 to 6, we would multiply by 1, right? To go from 3 to 2, we would multiply by 1. Wrong. So, no. Rectangle B is not similar. Rectangle C is similar. Rectangle C. So here's what we just did. Here's our proportion. 3 over 6. This is rectangle A equals, they're supposed to be proportional, it's supposed to be equal, 2 over 4, 2 corresponds with 3, 4 corresponds with 6. Okay, these are supposedly equal, meaning we could simplify both of these problems down to 1/2. 1/2, and we can. That's how. Alright, let's go ahead and take a look at example 2 and 3. The figures are similar. Now we're going to solve for x. So what we're going to do is we're going to set up the proportions. We talked about this last year. Well, you talked about this last year with your teacher. And here's how we set up a proportion. Blank over blank equals blank over blank. Two fractions are equal to each other. Okay, we call this a proportion. We're going to go x, because that's our missing side, x, corresponding to x is 6, 6. These are corresponding sides, so I put them both on the same, both in the numerator. Okay, and 6 and 9 are corresponding, and I put the x and the 6 in the same fraction because they're from the same triangle. I put the 6 and the 9 in the same fraction because the 6 and the 9 are from the same triangle. Corresponding, same figure, same figure. That's how I set up my proportion. Okay, now you learn this butterfly method, I think is what you guys called it. Okay. Cross product property. 9 times x is 9x equals 6 times 6 is 36. The last thing that we need to do is divide by 9, and now we have x by itself, that's what we're supposed to do. Solve for x. And it happens to be 5. What am I saying? 5. 4. It has to be 4. 4. 4 times 9 is 36. So this side right here is 4 feet. 4 feet. All right. Let's look at number 3. Setting up the proportion, we'll get x over what corresponds with x, 12 equals 12. Same shape, 14 over corresponding to 14, 7. All right. Cross product property. Okay. X times 7 is 7x. 14 times 12 is 168. Get x by itself, divide by 7, and x equals 24. So this side right here is 24 centimeters. All right, let's go ahead and go into example 4. This is supposed to say 4. Whoops. Okay. Example 4. An artist draws a replica of a painting that is on the Berlin Wall. The painting includes a red trapezoid. The shorter base of a similar trapezoid is in the replica is 3.75 inches. What is the height of the trapezoid in the replica? Okay, so let's set up a proportion. Okay, I'm gonna start with h over 12. Those are corresponding. Oh, what am I doing? I didn't say to set it up that way. H equals 12. There we go. Corresponding. 3.75. Corresponding. 15. All right. Cross product property. 15h equals 12 times 3.75 is 45. Get h by itself, divide by 15, and h equals 3. So, what is the height of the trapezoid in the replica? 3 inches. All right, and you can do this. You can now solve for missing sides of similar figures. So here's your 3 on your own problems that I would like you to try. Okay, the first one, you're determining if they are similar. The directions determine if they are similar. Okay, the second ones, are the two rectangles similar? Explain your reasoning again. And then third one, solve for the missing side. All right, number 1, you should have said no. Number 2, yes. And I should see that you'd use some proportions work there to make sure it did work out. And number 3 is 6. Okay, go ahead and answer that essential question. Your checkpoint is up and running. I hope you guys are having a good day, and I hope to see you at the gallery. Okay, you should all come out and check and see your peers' work. Bye, guys.